So we have another type of comparison test today. Last time we had the direct comparison test and we looked at a series that was very similar to this one. The only difference last time was that we had a plus there in the middle. So let's see if we follow the same process that we had last time, what happens, and then we'll see why we need this other comparison test. So last time we would have compared this to, well, we would have noticed that the terms are always positive. Yeah, if I plug in numbers bigger than or equal to 0, we get positive terms. We compared this to the series 1 over 3 to the n, which is a convergent geometric series. And let's see what happens when we try and do this comparison. So we need to figure out what has bigger terms. We notice 3 to the n minus n is less than 3 to the n. So 1 over 3 to the n minus 1 is greater than 1 over 3 to the n. So our terms are bigger than something convergent, which the direct comparison test didn't tell us anything about. If we have terms that are bigger than something convergent, our thing could still diverge. So in this case, the direct comparison test tells us nothing. And we need another type of comparison test. And that's going to be the limit comparison test. So the limit comparison test tells us start with two series that both have positive terms. So we have the same conditions that we had before. We have to start with positive terms. And then what we do is we look at the limit of the ratio of these. And as long as we get a positive finite number out, then both series do the same thing. They either both converge or both diverge. So let's see how that works, because that's a little funky. So let us look at this series that we had before. This is going to be a little messier than most of the examples we do. So let's compare this to something that has positive terms that we know what happens. So let's compare this to the series 1 over 3 to the n, which is the thing we tried to compare it to before. We know this is convergent because it's geometric. And so what we'll do for the limit comparison test is we look at the limit as n approaches infinity, and we look at this thing divided by this thing. So we have 1 over 3 to the n minus n over 1 over 3 to the n. And now we have to figure out what that limit does. So we can flip this bottom fraction and multiply by it. So when we do that, we'll get a 3 to the n over 3 to the n minus n. And now we need to figure out what happens with this limit. 3 to the n is going to be much bigger than n, so these things are going to control what happens here, and this will not be contributing nearly as much. So that's going to just be 1. And the limit comparison test tells us as long as our final answer is a positive number and is finite, so not infinity, then we have good things. So this is good. This is positive and finite. We need to write that. And so by the limit comparison test, we'll call it LCT, limit comparison test, both series do the same thing, and we saw that they both converge. Okay, so that's how the limit comparison test works. Oftentimes, if we have a messy polynomial over a messy polynomial, sort of like this one, and these aren't all that messy, the limit comparison test works nicely. So in this case, we have positive terms if n is big enough, as long as this thing ends up being positive. So I would say if n is greater than or equal to 2, if n is 1, we get a negative term, but that's okay. As long as these terms eventually always become positive, we're good. And so let's compare this to, let's take the highest power in the numerator and denominator. That's always going to be a good trick. So that's 1 over n. This is the harmonic series, which diverges. We want to make sure we are comparing it to something that we know what happens. And so we'll look at the limit as n approaches infinity of this guy divided by this guy, the thing that we're comparing it to. So we have n squared over n cubed minus 3 over 1 over n. So that's the limit as n approaches infinity of n squared over n cubed minus 3. We multiply by the reciprocal, n over 1. And hopefully this is a limit we can compute. This is n cubed. Sorry, my 3's are looking really messy today. N cubed over n cubed minus 3. Once again, we just take the highest powers. That ratio gives us 1. We don't always get 1 out in these, but we oftentimes do. So this is positive and finite. So by the limit comparison test, both series do the same thing. And what did they do? They both diverged. Okay, and we'll get a lot more practice with the limit comparison test during class.